Uh, Hello everyone. Today we're going to talk about snow loads, and I'll show you how to calculate the snow loads, and finally I'll give you a sample FEPE or SE question for those who are going to take the licensing exam. So snow loads are very important for a particular structural design, and this can be shown by looking at the picture on your screen. This is the Hartford Civic Center that collapsed mainly due to snow loads. We had, I think, a 10-day snow period, and so this roof had accumulated snow, and because of the weight of the snow, it ended up collapsing. And this happened actually 6 hours after university game. So you can imagine if the collapse had happened just before or just during the game, what would have happened. So next, we are going to focus particularly on flat roof snow loads. And as you can imagine, snow loads can vary so much even within a small area. So let's say within your town, we might have one section that is snowing heavily and the other section that is not even snowing at all. Also, within your country, we might have regions that have extremely large snow loads. And so in America, we use ASCE 7-16. That is currently, of course, it keeps changing to determine the ground snow loads. And if the area is complicated, then you'll need some case study for your area. Oh, and for those who are interested in calculating this snow loads for a sloped roof, please check ASC 7. Next, so this is the formula, very simple formula to calculate the roof snow loads for a flat roof. And just for your information, a flat roof has a slope that is less than 5 degrees. And also from the equation, you can see we have some three factors, actually four factors. 0.7 is a factor. Uh, this simply means that the ground snow load should be reduced uh, compared to this the roof snow load. That's why we multiply by 0.7. And then the other factors depend on the exposure or the temperature in that particular structure or how important that particular structure is. So we are going to talk about these factors next. So exposure. Uh, we have surface roughness B. This is one particular exposure, and if you're in an urban or suburban area, so according to ASC 7, you are in a surface roughness B. So you can see the picture on your screen, for example. Next, if you are in an open terrain with scattered obstructions, then according to ASC 7, you are in a surface roughness C. That's your exposure. And then finally, if you are in a flat, unobstructed area, or in like a water surface, on a water surface, then your surface roughness exposure is D. So that's it for the exposure. So I have a question for everybody. So what is the exposure for this particular city? So if you know the answer, please leave a comment below. Next, these are the exposure factors uh, that we use in our snow load calculation. You can see we basically have three types of roof exposure, which is fully exposed, partially exposed, and sheltered. And then depending on the terrain category, you'll have a different factor. And something I'd like to point out is here, a building in a fully exposed area simply means that the snow will be blown off, and so we have smaller exposure factors compared to a building or a structure in a sheltered area, which simply means that the snow will accumulate. So we have factors that are higher than an area with a fully exposed roof. Next, we have the thermal factors, and of course it also depends on the temperature of the building. So here 1.2 and 1.3, these are higher than the rest, and it simply means that the heat from your structure will not melt much of the snow. So if you are designing a freezer building, of course the snow on the roof is not going to melt as much as when you are in an area with higher temperatures. So of course we have higher factors to accommodate for that situation where the snow is not going to be melted. Next, we have the importance factor. Again, this depends on the risk category, from risk category 1 until 4. So category 4 is these are very important structures, so we need to multiply by a higher factor when designing these structures. And basically that's it. So here's a sample question for those who are going to take the FE, PE, Civil, or the SE exams. So please pause the question, try and do it by yourself, and then you can continue and see how we're going to work out. So basically you're given the ground snow load of 80 PSF. Then you are told that the exposure terrain is C, and the trees provide shelter on all sides of the structure, and it's also a heated building. Okay, and then you're told to use ASCE 7 to design or calculate the design snow load on the roof. And of course you're told to assume a flat roof. So the first step is to find all the necessary factors. It's very easy. So we've already talked about these factors. For example, the exposure factor is 1.1 according to our information. And the building it's a heated building, so the thermal factor is going to be 1.0. And the importance factor, because it's a risk category 2, that is the standard residential occupancy, then the factor is going to be 1.0. And then you're already given the ground snow load, which is 80 PSF. So then the final step is just to plug in the factors and the value of the ground snow load in that equation, and you'll find that the design snow load is going to be 61.6 PSF. Very easy, very straightforward. So for those who are going to take the FE, PE, SE exams, good luck. And of course, if you have any questions, please leave your comment down below, and I'll be posting some more questions and some more discussion topics in the near future. So please subscribe, and see ya. Good luck.